Okay, I wanted to give a little update on my endeavors building projectional editors for the web with the Elm programming language. So I used the state machine language by Fowler as an example to show what's currently possible. But before we look at the code, let's just look at that example and see some of the projections that are currently available. So I start out with a state machine that you might be familiar with. I already have a name here, which I can edit. It's just an input field, which updates my model while I type. And we have some states, some events that work the same way. I can add some and delete them again. So nothing too fancy here. What I actually wanted to show you is the states and the projection as a graph. So we added a state. Let's call it idle, and on the right side we see a projection as a graph of the states and the transitions. So let's add a second state. Let's call it active, and when the door is opened, we go into the active state. So we have a simple graph on the right side using some force logic in order to position our nodes based on the connections. And we can have some drag and drop action here going on, which is a little bit nicer when we have more than two nodes. So let's add some, waiting for draw. And let me just put the transitions here. So if the light goes on, we go in waiting for draw. And when I add a transition to a state that doesn't exist yet, so draw opened, can try that as well. Waiting for light. So let's just add that, waiting for light. So as soon as the names match, then our graph draws the connection. So it's based on name referencing, which is arguably not perfect. So if I have two things with the same name, then it gets confused. But for now, it's good enough to make a proof of concept whether or not this works. So as you can see, when I move around the nodes a little bit, then we get this weird selection stuff going on. This is because the text here is actually input fields that I can edit as well. So it's not just a read-only projection, but it's actually an editor. At least it has some input fields here for now. So yeah, that's what I wanted to show. Let me just add some final state here on the panel. And then if the light goes on, we go into unlock panel. Just wanted to show this little snap again. And this is actually not right. We wanted to have draw open here and light on unlock panel. So now it's correct. So yeah, this is also something I added here, by the way. We have this drop down, some sort of very, very basic autocomplete again, just looking at the global scope for names that match the type of this reference cell, and then collecting the values. So now let's look at the code necessary to build examples like the one we just saw. If you're not familiar with Elm or similar languages, some of the stuff might seem a little bit weird, but just to give you a high-level idea of how the API works and the basic idea behind it. So don't be too upset about the syntactical details. So for our state machine language, we define a module called state machine, and we import three other modules which we need to build this application. The editor module is there to define our transformation from our own domain to the cell domain living in the editor. And it handles all the effects that the editor might give the user. The runtime basically puts everything together, and the structure module allows us to build abstract syntax trees for our own domain, and it's also used by the editor to build the abstract syntax tree for the editor domain, if you will. Okay. First thing you want to do is define your custom type, which you can give a random name. I decided to call it domain to highlight that this is our domain that we define, and we just list the different variants of things that can live in our domain. So it's a state machine, it's an event, state, and transition. These are just the things that exist in our domain. The main thing you need is a main function to produce a program so that we can see something on the screen. We ask our runtime module to create a program for us by means of calling the projection function. So the projection function needs two things. It needs our initial model, which in this case is just an empty state machine. So this program, when I run it, will just start with nothing but a root node of type state machine created by this function. And the second ingredient is the transformation from our domain to the cell domain. So we have nodes of type domain, and we produce nodes of type cell. The editor could be written in one function, but it's more convenient to have it split up a little bit. By convention, we start with the root cell, and I created this API with kind of like a fluent API in order to build up our editor in a declarative way. So the root cell with whatever the editor state machine function produces. So our actual editor starts in this function, and it's a vertical split cell with two ingredients. First ingredient, second ingredient. So if you remember, our editor has a left side and the right side. This is due to the fact that we declare a vertical split cell here. And on the left side, there lives a vertical stack. So things are stacked from top to bottom. And on the right side, there lives a graph. By definition, only the first two children of a vertical split cell will be seen. So you could add more stuff here, but wouldn't make a difference. Okay, so let's look at this part, the left side. We have a vertical stack cell with three things. The first thing is whatever this function produces, and which is basically the first line of our editor, name colon as a constant cell and an input cell for actually putting in the name. Let's go there. So you can see that this is a horizontal stack now. Things are ordered from left to right. We start with a constant cell, name colon, and then an input cell for the name of our state machine. We also add a margin at the bottom to give the editor a little bit, or the user a little bit breathing space here between the things. This is done by this API. Okay, so this is already our first line of the editor on the left side. Then the second thing is for editor events. We pass in the state machine and we make a decision. We use the let expression in order to define a value based on whether or not the state machine has roles or not. So we ask the state machine under its custom role called role events if there's something. If there are no events, so if the result here is an empty list, we show a placeholder cell that allows us to put a first event there. And if there are events, we basically just map them over the editor event function and produce input cells for the name of the event. And an input cell is special in terms of default effects. So each input cell already by definition handles keyboard input. So when we change whatever property is shown, then the effect that is by default added here will be triggered and update our domain model. We can also add custom effects if we want to, which we do here. So we want to be able to insert new events based on this constructor function here, which creates a new node of type event with an empty role, with an empty name. And we also want to be able to delete events again, so we add the deletion effect. So these two effects basically allow us to do the following thing. The insertion effect is mapped currently to the enter key to do that, and then we have, by means of backspace or delete keys, the option to delete things again. Okay. And yeah, the states editor is basically the same thing as the events editor, so you can look at that if you want by yourself. Just wanted to look at the graph cell real quick. So we basically say we want to show a graph on the right side of our vertical split, and it consists of vertices and edges, and the vertices are produced in this function, and the transitions are used to produce edges. So we pass in our state machine again as the root, and then we say, well, just to highlight the pipe operator to the other side as well, we basically say, give us all children under your default role, which are all the states by definition, and map them over this function. And this function basically just produces vertex cells using the name of the state. So this is the reason why we see the names of the states here, and because I designed it that way, by default these are editable cells, so I just changed the name of the state, and there's no way of putting a transition here at the moment because the references don't update automatically, something for the future, but just to show that we can edit both on the left side and on the right side. Okay. What else? Well, let's look at the transitions. They are a little bit more involved, but easy enough as well. We basically say, give us all the states again under the default role of the state machine, because the transitions are defined inside the states. So we first have to get all the states and then map these states over this function. So this function basically gets one state after the other, and we basically say, well, for everything under your default trait, which is all the transitions, map it over the edge function, which is a local function, which I defined here inside the let's expression. So this edge function gets the transition, and it produces edge cells, which are labeled by the event reference, currently not used in the projection. More importantly, we tell the names of the source and the target for this edge. So what do we want to connect? And we also pass the domain node as a context to this edge. So yeah, that's pretty much it. I think a very straightforward API so far. Let me know what you think, and thanks for watching this video. I appreciate your feedback.